Hello again. Welcome back to Pedagogical Corner. Today's episode is dated June 15th, 1997. A pedagogical discussion by Jonathan Tennenbaum, Part 1, Demystify the Golden Section. Last week's inquiry concerning Leonardo da Vinci's principles of machine tool design brought us face to face with an old friend, the significance of the so-called golden section. Although this topic has been discussed many times in our organization, I think there still exists a residue of mystification remaining to be cleared away. Often enough in the past, mere mention of the golden section was liable to evoke fits of embarrassed hand-waving and numerological free association from supposed experts, while the issues that really bothered people and have to be worked through in a rigorous way were not adequately addressed. Lynn, of course, has dealt with the golden section repeatedly and from the highest standpoint. For those who are resolved to break through on this issue, I would particularly recommend rereading Lynn's essay on the subject of metaphor, Fidelio Magazine, Fall 1992, and his book-length study, Cold Fusion Challenge to U.S. Science Policy, Schiller Institute, August 1992, particularly Section 2, entitled 6 of the Crucial Discoveries in Modern Science. The following pedagogical discussions are intended to provide some useful geometrical homework on these matters, while adding a fresh view of the subject, thereby assisting the reader in triangulating the essential points to be mastered. On the most elementary geometrical level, we have the problem that only a few people, with the exception of Chuck Stevens and a few others perhaps, have actually worked through the geometrical constructions which characterize the relationship of the regular solids to their inscribed and circumscribed spheres. Yet the essential discoveries of Leonardo and Kepler were all referenced to Euclid's original treatment of exactly that issue, as later reworked by Leonardo and Pacioli in the book Divine Proportion, and read from the standpoint of Nicholas of Cusa's concept of an evolutionary ordering of species analysis situs. To present the golden section merely as a ratio derived from the regular pentagon were a wild fallacy of composition. Even on elementary geometrical grounds, the only admissible approach to the golden mean is one which defines it as the unifying characteristic of the way in which the higher species sphere bounds the lower species regular solids or spherical divisions. The really crucial problem, however, lies in the way people read or misread the ontological significance of such elementary geometrical topics. Having witnessed many a member's more or less frustrated attempts to master the golden section, I am reminded of an often cited anecdote from Russia. One evening, a man lost a ring in a dark corner of a park. Instead of looking for it there, the man spent hours carefully searching under a nearby street lamp. When a passerby asked the man why he kept looking in the wrong place, the man replied, "I'm looking here because here is plenty of light." People who consciously or unconsciously are wont to stay away from the dark, uncomfortable area of rigorous creative thinking won't find an answer for the golden section, no matter how exhaustively they search for it. There does not, nor could there ever exist, an explanation of the sort which could be acceptable to the Aristotelian norms of contemporary classroom education. The golden section, as Leonardo and Kepler understood it, and as Lynn develops it further, is an idea. It does not exist in the objective world of geometric forms per se, nor does it arise from any amount of empirical evidence taken by itself. In his piece on cold fusion, Lynn demonstrates in rigorous step-by-step fashion the inseverable relationship between Leonardo and Kepler's reading of the golden section and Plato's notion of hypothesizing the higher hypothesis, as that connection becomes uniquely intelligible from the standpoint of physical economy. Lynn adds an admonishment which the present author found most useful. Quote, look at the golden section from the standpoint of what Plato and Cusa knew before Leonardo and Kepler. Do not attempt to read it as if Leonardo and Kepler were such fools as not to have studied intently the work of Plato, Archimedes, and Cusa. A few lines further, Lynn adds, until we have grasped the fact that true science is subjective in this way, that its validity is located essentially in that anthropocentric subjectivity, we do not have the means to read intelligibly the crucial argument of any among the founders of modern science. The following discussion should cast some further light on the cited point, which is crucial to any adequate understanding of the physical significance of the golden section. I would not be surprised if there were a considerable number of persons who routinely skip over Lynn's written discussions of certain scientific topics, rationalizing that practice to themselves by the argument that Lynn intends these as merely optional illustrations of general points. The assumption is that the same concepts could be communicated just as well without recourse to such difficult and specialized topics. In an extreme case, we might encounter the following train of thought. Quote, oh yeah, Lynn is really just talking about the higher hypothesis or negentropy or something like that. I already have an idea what those are, so why make such a big deal of circular action, the golden mean, Riemann, contour, and so forth, which just confuse me and cause me mental suffering? End quote. Apart from exhibiting the typical intellectual sloppiness and laziness of our baby boomer generation, the quoted folly might usefully provoke us to consider quite the opposite thesis, namely, that the universe is constructed in such a way that it were impossible to master the notion of the higher hypothesis except through the included means of certain uniquely defined series of geometrical discoveries. By geometrical discoveries, I do not mean to imply that the discoveries emerge from the domain of mathematics per se. Rather, it is the provocation provided by otherwise resolvable physical anomalies which causes us to evolve new species of geometry in such a way as to permit us to integrate those anomalies as new dimensionalities in a revised, unified conception of multiply connected physical action. It is quite remarkable that up to the present time, those fundamental geometrical discoveries so defined all have the direct or indirect effect of redefining or unfolding, as it were, the significance of the circle, circular action, and the sphere within geometries of ever higher order. So it is with the Pythagorean discovery on incommensurability, the proof of transcendence of circular action as conceived by Nicholas of Cusa, the reworking of the universal significance of the golden section by Leonardo da Vinci and Kepler, and C.F. Gauss' introduction of the complex domain's anti-Euclidean geometry. Through all these transformations and revolutions, the circle and sphere remain the same as visible forms. The crucial thing that changes is how we read them. Might not the key, the physical significance of the golden mean, lie in that profoundly subjective condition of human existence? Could it be that the circle, sphere, and golden section derived harmonics are embedded in the structure of the universe itself in the form of transfinites, undergoing a continuous process of conceptual redefinition through validated experimental discoveries as necessary characteristics of any pathway for the survival and development of the human race? With these issues of method in mind, turn now to some geometrical experiments. If carried out thoughtfully, the insights from those experiments can help to sharpen our appreciation of the same points when we return to them later. As Kepler himself emphasized, his own reading of the significance of the sphere and regular solids was based on Nicholas of Cusa's development of the concept of lawful ordering of axiomatically separated species, analysis situs. The sphere bounds as a higher species. The regular solids, with all their mutual relationships and quasi-regular offspring. The golden mean should signify, first of all, a unifying characteristic of the relationship between the lower, regular solid, and higher, spherical species. That simple remark already points to something wrong with the commonplace approach in which the solids are constructed as isolated entities, typically out of sticks fastened at the ends by gluing together regular polygonal faces or similar means, without reference to inscribed and circumscribed spheres. Constructions with circular hoops have the same drawback, except insofar as we observe the way the curvature of these hoops and their mutual relations are determined by an invisible spherical bounding. Why is it not permissible to first construct a regular solid and then create the inscribed and circumscribed spheres, as it were, by spinning the solid? Because, I say, that would misrepresent the true ordering of the species. The very existence of the regular solid and virtually every step of any proposed construction presupposes and embodies circular action applied to results of circular action. What, after all, is an angle? Just look at the constellation of angular displacements which accompanies the birth of each and every singularity, vertices, edges, and faces of a solid. Accordingly, I propose the following task be explored: to inscribe into any given sphere by construction each of the 5 regular solids. Similarly, to circumscribe a given sphere by each of the 5 regular solids. In the first case, the solid is to be constructed in the sphere's interior, that its vertices touch the inner surface of the sphere. In the second case, the solid is to be constructed around the sphere in such a way that the midpoints of its vertices touch the sphere's outer surface. Try to do the construction in 2 ways. 1, by means of classical Euclidean geometry in 3 dimensions. 2, by rotations of the sphere. In the latter case, the task is to construct the great circle division of the spherical surface corresponding to each of the regular solids. For the purposes of this exploration, we may consider that a given rotation generates, as singularities, the corresponding poles and equatorial great circle on the sphere, as well as the arcs traced by already generated singularities. Observe the relationship between the 2 modes of construction. The point of this exercise is not necessarily to complete all the proposed constructions immediately. Indeed, people will observe that the case of the duodecahedron and icosahedron gives rise to rather extraordinary difficulties. Those difficulties are very much connected with the unique role of the golden section. The important thing is to explore the terrain and to pick up and conceptualize the paradoxes which arise in any given approach. Readers will probably find that the inscription of an octahedron presents itself as the simplest case and also opens a pathway of approach for the cube and tetrahedron in that order. Note that the constructions involved, at least the most direct ones, all share certain common features. Observe also that analogous methods fail for the duodecahedron and icosahedron, although the latter provide a pathway for constructing the first 3.